Chapter 18, Will a precipitate form? Will a precipitate form if 50 milliliters of 0.20 molarity sodium chloride reacts with 50 milliliters of 0.060 molarity lead nitrate? And they're giving this the KSP of lead chloride. That should be a hint as to what we're looking for later. So when we do problems like this where we're figuring out if a precipitate will form, we need to be looking at, oh, that was fun, at Q versus K, our reaction quotient versus our equilibrium constant, KSP here. If our Q value is greater than KSP, then that means we have a precipitate. A precipitate will form. If our values are equal, then it is saturated. It's at saturation point. It's at its saturation point. And if our Q value is less than our KSP value, then it has not yet reached saturation. So there's your mini lesson on predicting if a precipitate will form. So step 1, but you can't guess what step 1 is. Identify the major species. So here we are working with two different species. We have NaCl, which is a salt, metal plus nonmetal, and lead nitrate, which again is a salt, metal plus a polyatomic, still a salt. Okay, so now we're going to use that to write out the reaction. Let's see, we have, since we are mixing together two different substances here, I'm gonna, well, we've never really written them all out together in one big line, but we can here, so I'm gonna go ahead and do that. So these two get added together and they form 2NaNO3 and lead chloride. And if you wanted to use a double arrow here, that'd be fine. We are dealing with KSP, which allows us to use double arrows. Okay, so now out of this list, is there anything here that you see that is insoluble? That's right, you have to refresh your memory on solubility rules. So if you don't remember, I'll tell you right now, it's lead chloride. That is a solid. Now if we have too many of our reactants, then we might end up with some of that solid building up. On these precipitate problems, you need to write the net ionic. I don't think we've had to do that yet in any other problem. So if you were to write out the net ionic, our sodiums would cancel out with each other, our nitrates would cancel out with each other, our lead, however, would not, and our chloride would not because they're tied up in that solid. So I'd end up with 2Cl-. If you want me to show you this on a whiteboard sometime, just let me know. That is going to react to form lead chloride. Okay, so now that we've done that, let's go on to step 3, where we would usually write out our equilibrium expression, but first check, is there a dilution? Has it been diluted? Yep, for the first time in a while, we have a dilution. Don't forget that step. It happens sometimes. So I'll do this twice, once for each compound. And for both of them, I'm using M1V1 equals M2V2. So for our sodium chloride, we know it starts out at 2.2 molarity and 50 milliliters. And I'm trying to find its new concentration and its new volume. Let's make sure we get the right number here. It reacts with 50 milliliters of something else. So with means, oh, we're adding them together. So I end up with 100 milliliters. So I end up with an M2 of 0.10 molarity sodium, as well as chloride, because they're 1-to-1 within sodium chloride. So now let's do our lead nitrate. Here we have 0.060 molarity, also in 50 milliliters to begin with, and its new volume. So new concentration here is 0.030 molarity lead, and we have 2 nitrates for every lead chloride, so that means it's going to have double the concentration. If you'd like to see that done out, you could always do a mole ratio. So now that we have these concentrations, let's write out our equilibrium expression. Now remember, you can use this expression both for Q and for K. It's just what they're equal to that is different. So we could say our KSP is equal to, now if you'll notice up here, they gave us the KSP of lead chloride. So if that's the case, then that would mean that our product for that KSP would be lead and chloride. So those are what I'm going to put up here at the top. Remember, for KSP, you put the ions, the dissolved ions, at the very top, and the solid would go on the bottom. However, we don't include solids, so that doesn't go in. Okay, so there's that. Let's move down a little. Now, finally, I'm going to solve for Q and then compare, that's an and symbol, and compare with our KSP using the rules I wrote on the right-hand side. So remember, Q is when you plug in concentrations at any point in time. So I'll use this same equation and I'll plug in the concentrations from above. I had, let's see, what was my lead? 0.030. And my chloride, oops, that needs to be squared, should be 0.10 squared. Okay, so my Q value is 3.0 times 10 to the negative 4, whereas my KSP was 1.6 times 10 to the negative 5. So in this case, I'll write this in black, since Q is greater than our KSP, we know we'll have a precipitate. Precipitate. And that's our answer. So remember, when you are dealing with figuring out if a precipitate will form, you need to write out the reaction, including both of the compounds that are being mixed together, two different salts most likely. You're going to create a net ionic equation. You're going to figure out the dilution. Use that to figure out your different ion concentrations. Write out the equilibrium expression for the net ionic so you know which ion concentrations you actually care about. Use those, figure out Q, compare Q to KSP, and you'll have your answer.